Okay, today's video we are looking at expanding brackets. This is for my Year 8 Mathematics class. This one can still get some getting used to, but the idea, I'm going to give you a visual and that's going to help you figure out how to get the correct answer every time. So it's actually not difficult to do. All it requires is just a little visual memory trick. Here we go. So we got to make sure we can do the following. So we know what the distributive law is. Can you use it to expand brackets, and can you gather up like terms once you are done? Before we get into the actual distributive law, I do want to emphasize a visual of what brackets are, because if you understand a bit better what a bracket is like, then a lot of the maths operations we do with them should make a bit more sense. Whether we're doing a bracket and then there's a power next to it, for example. So a way to think about brackets, I want you to think of them like a bag. So for example, there's all drawstring bags. This is the visual that I have in my mind when I am using some maths that has the brackets. So for example, if I've got something that says a plus 1 and then there's brackets around it, I'm imagining that this bracket is basically a bag, and inside that bag there's a letter A, and there's also, a plus 1 inside. So to give you a better analogy of this, I'm just going to go down here. I'm going to use blue and green marbles. Okay, so I've got 3 blue marbles. I'm going to put them in the bag. I've got 2 green marbles, and I'm going to put them in the bag as well. Okay, why do I have them in a bag? What's the point? Sometimes it is easier to gather things up like this in mathematics. It just cleans up the expression. There's less and less things to write when you write it all out. We will use the brackets almost like a zip file. You sort of gather things together and you stick them in one place. So an occasion of this would be something like that. So if I have 2 of these bags, how many blue marbles will that be? Well, I think you all get the idea. There should be 6 blue marbles, and then there should be 4 green marbles. And that is pretty obvious to you because of the visual I've given to you. If I translate this exact problem into the algebra form, now, I'll color them in to help you follow along with me. I'm just using the letter B to represent blue marble and G for representing a green marble. What you just mentally did, you probably just looked at the 2 times all these blue marbles to get the 6 blue. So we have our 6 blue marbles when we're finished. And then you did the same trick with the green marbles. So we have also the 4 green marbles. What we are effectively doing here mathematically is getting rid of the bracket. Sometimes we will need to gather things up into a bracket, but it does sort of lock us out of doing some mathematics tricks or techniques. And so in some occasions, it is useful to know how to break open the brackets, expand it all back out again, and then that allows you to sort of clean things up or do other math operations like multiplication or division, for example. So this is the process of getting rid of these brackets. Right, so now you get the visual. Think of every time you see a bracket, I want you to think of a bag and whatever is inside of it. Distributive law, sorry. I've always called it distribution, but anyway. It's a method used to expand the brackets. And the idea is you must apply the multiplication to each term inside. So if you recall in a previous video, I think it was gathering like terms. It was meant for my Year 7 students. But the idea is that you can identify what a term is. So this will be a term, and this will be a different term. And they are separated by these plus or minus signs that appear in between a chain of things in a expression or an equation. And the key part of identifying terms is that the plus or minus sign this bit here is supercritical. It belongs to that 3, or it belongs part of this 3b term. Presently, there's nothing in front of the a, so we assume that's a positive sign that is there. It's just invisible right now. So when we are applying the multiplication to each term, we're basically going 5 times the first term, and then 5 times the second term. And that's how you would calculate the result. Let me just show it to you. So that'll be 5 times the a, that'll be the first step, which gives me 5a. And then I do the second term here, which is 5 times negative 3b. Well, the b is not going to do anything, so it's just going to stay there. Let me just focus on the coefficients, or the numbers. 5 multiplied by negative 3 is negative 15. And so I've expanded the brackets and I've finished it. Look, I realize this example is not that great, but when I give you the next visual, I think the answer will be very obvious. I always think of distribution law as somebody is standing outside of a fortress and firing artillery into the fortress until everybody is dead. So here's my little fortress. Now you can see those brackets. Instead of the bag, which we had over here, the bag was representing the brackets. I want you to imagine the walls of a fortress. So we're sort of looking at a cross-section view of a fortress. And we've got some people here who are trying to fire into the fort. And if you recall in algebra, the standard practice is that if you've got things side by side like this, it generally means multiplication is happening. Okay, so that means 5 times the entire bracket. So here we go, 5 times the letter A. That gives me 5, let me just put it in purple now. That gives me the 5A. Now I'm going to do 5 times the negative 3B. So again, the letter is not going to do anything, so I can just copy the B as it was, and I just focus on the numbers themselves. So the 5 times the negative 3, that gives me the negative 15B, and that's my final answer. And with this fortress analogy or visual, I think you get the idea of what's going to happen if the fortress has more people inside of it. So here we've got 3 terms inside, so you can see here's the first term, second term, and third term inside of the brackets. So if we multiply this one out, so 3 times the 2x, the x is not really doing anything, so I just put the x there and nothing happens to it. 3 times 2 is 6, so that becomes a 6x there. I guess I should probably pause here. Why am I not doing anything with the letters? Why did I just say in the previous example the b is not doing anything, so I just copy it down? That's just like an end result of what's happening. I guess if you translate the letter into something meaningful, then I think it's obvious. So for example, if I change the letter X for a moment here, if I change it to an A, okay, so, and let's say this letter A says apples, okay? Now when I do the process of multiplying it out, so 3 times 2 apples, that's going to be 6 apples. So it's like the letter's not really being changed in any way when you're multiplying by a number in the front. Let me just rewind time here because it looked a bit messy. There we go. So we've done the first term. Now I progress to the next term, which is pink. I don't have a color pink. Let me go to find one. There's a nice pink. 3 times the positive 7. So 3 times 7 is 21. So it's 21, and it's positive 21, so I put the plus sign there. That's where this sign comes from. It comes from the result of doing this times this. If the answer is positive, it ends up being a plus sign between. If the answer is negative, the answer becomes negative in between. Okay, let me rewind again. The highlighting is a bit too much right now. Now we're going to do purple. I'll change to a stronger purple. Why not? 3 times this term here. So 3 times the negative 9y. Well, I'm not doing anything with the letter y, so I can just write it down. Now I just focus on the numbers. 3 times negative 9 will be a negative result. So I'll put a minus sign here first. 3 times 9 is 27. And we are done. That's the finished expansion of the brackets. Okay, now that you get the main idea, I just want to run you through different ways that I could probably make the question look a bit trickier. So that way, if you're comfortable with the way these tricky ones I've shown you, then you should be able to handle pretty much the everyday basic ones that are very routine. So here's a tricky scenario. All that's different this time is that I've introduced a negative number in the very front that's being fired into the fortress. So when I do my procedure, -2 times I'll color them in. I think maybe that'll be better. There's the terms. Okay, so the -2 multiplied by the 4a, I would get -8a. So if you imagine a representing apples, so I got 4 apples, and you do -2 multiplied against that, I get -8 apples. Now I do this one, -2 times -3b. Well, negative times negative is a positive result, so I put that down first. Now I can ignore the plus and minus signs and just focus on the rest. 2 times 3 is 6, and b is not doing anything, so it just gets carried along the ride. And we're done. So that one there is actually not very difficult. The only thing that'll really catch you is if you forget about this negative sign in the front of the line, and you might forget that trick where 2 negatives multiplied into each other becomes a plus sign. Let's do this one. Okay, so what have I done here to make it a little bit more complicated? Well, I've stuck with a negative number in the very front, but I've just added more terms. So here's a green term. I'll use a purple term, and this will be a blue term. So if we expand this one out, -3 times -2x, so that answer should be positive. So that plus sign will be invisible because it's at the start of my finished expression. So it'll be +6, and the x is not doing anything, so it just gets carried along. Now, I wanted to keep it colored matched. Let me just rewind. So that would be +6x. Now I do the -3 times the positive y. My answer should be negative, and it's 3 times the y, so that's 3 y's. Now I want to do 3 times the blue term. So I've got -3 times -5z, so that's a positive answer. Now just look at the numbers. 3 times 5 is 15, and the letter z just gets brought along for the ride. All right, this is my last little tricky scenario. What's going on here? Well, I've just got brackets times brackets. Here we just modify the distribution law where when we had a single character at the front, they were firing into everybody, okay? If I bring multiple people to the fight, it's going to be, let me color them in. This number, I'll color in all the terms, and then we'll do the work. It'll be this times everybody in the other fortress, but this green term, they're not sitting on their ass doing nothing. They're, of course, going to contribute to the fight, so they're also going to fire into everybody they can find in the second fortress. And that's basically how it works. So if we do the process, the blue times the red, so that's +2g multiplied by -g, that should give me a negative result. Now we just look at the numbers. 2 times the 1 is just 2. G times g, I've actually got 2 letters multiplied against each other. So now that's going to involve a power notation. So there's g squared. Or I could have written that as GG for good game or whatever. But that's g squared. I'm going to use g squared. Power notation is a shorter, more compact way of writing the math, so I'm going to use that instead. Now we're going to do blue times the purple. So I've got +2g multiplied against +5, so my answer is positive. Now just look at the numbers. 2 times the 5 is 10, and the g has nobody to combine with, so that just gets brought along for the ride. Now I am going to focus on the green's attack. So the green attacking the red we get negative times negative is a positive result, so I put the plus sign down first. Now I just look at the numbers. 3 times the single g would be 3g. Now we're going for the next attack, which is green times the purple. So we've got negative 3 times against a positive 5, so it should be a negative result. Now just look at the numbers. 3 times the 5 is 15. Have I finished? Well, I technically have expanded the brackets, but the thing I want to get into next is, if in doubt, always simplify whenever you can. I think for most people, when you ask them a question and you can say, I can give you the really complicated answer, or I can give you a very simple answer. Or if I'm teaching you something in mathematics, would you prefer the complicated explanation or a simple explanation? I think everyone would agree we'd like the simpler answer. So for this expression I have here, I can actually make it look a bit nicer by gathering up like terms here. So I can see that this term and this term are like terms. They can be gathered together. How do I know that these ones match? Because they have the exact same letter combination. Why doesn't this one match, though? It also has a letter G. Well, it's not exactly the same thing. It's actually negative 2GG in reality. It says 2 G's in that one and only 1 G in this one. So they're not exactly the same term. So the first bit, which I'll just color in here in green, it can't be gathered with the blue ones. So it'll just be left alone. So that's going to be negative 2G squared. And then I'm just going to add the blue terms together because they have a matching combination of letters. And once I've identified them, I just focus on their coefficients. So I got plus 10 and plus 3 gives me plus 13 G. And then I can copy down. Nothing's happening here with the negative 15 on the end, so I just bring that one down. That does look a bit ugly. Let me just rewrite all that, but a bit neater. Just undo all that color. So it would be the first term has no friends, so it doesn't get gathered with anyone. The two blue terms, I add the coefficients, which is the 10 and the 3. And they're both positive, so that makes positive 13G. And I take away the 15, because this one's being left alone. Okay, another example of just gathering up like terms once we're finished. It's just like cleaning up your mess when you've blown apart the fortress. So let's do the expansion procedure first, and then we can start to gather. So 3 times the 2b gives me 6b's. 3 times the positive 5 will give me a positive 15. Geez, 15 is showing up a lot in these examples. And then this one here is outside of the fortress, and nobody's multiplying against it, so it just gets brought along, and nothing's happening to it. Now we go looking for like terms. I can see this term here and this term here match, whereas this one has no friends at the moment. It's the only one with no letters on it. When we gather up like terms, we just sum together their coefficients, bearing in mind if there's a plus or minus sign in front of the coefficient. Here they're both positive, so positive 6 and a positive 3 makes positive 9. And then the yellow one is just left alone. And we're done. That's basically all the tricks for distribution law, or distributive law. And I hope the analogy of this little fortress attack will help you.